Cameron, and I'm the product lead for Go at Google. I've been a PM on the Go team for almost 3 years, but I only took over from Steve Francia, our MC, as product lead about a year ago. Steve has some pretty big shoes to fill in this community, which is kind of a pro and a con, but I think most of all, we're all just grateful for his work over all the years. So today, I'm going to tell you about the state of Go. And the short of it is that the state of Go is strong. But before I tell you why, I want to recount how we got there. Now, I wasn't there, but the story is that during a 45-minute C++ build sometime in 2007, Rob Pike and Robert Griesemer scribbled together a vision of what would ultimately become Go. According to Rob, a couple of Google employees had recently given a talk about all the new stuff that was going to be in C++ 11, and he counted something like 35 new features that were being planned. And somewhere in there, he asked himself a question. Did the C++ committee really believe that what was wrong with C++ was that it didn't have enough features? Surely it would be a greater achievement to simplify the language rather than to add to it. And Rob made this observation in the midst of a period of tremendous growth at Google. The breadth of Google's products and services was growing, usage of these services was growing, and the engineering teams at Google that were building and maintaining all of it were growing too. So this slide shows us how Google's headcount grew between its IPO in 2003, when it had a little over 1,600 employees, to when Go 1.0 was released in 2012, when Google had grown to over 50,000. And this meant a lot more people writing a lot more code, ensuring all that complexity worked well together, didn't break, was readable, all of that. It carried a lot of overhead. And since Google's business is all about scale, this problem was only going to get worse. And this is where Go was born. Google was struggling with its scale, especially internally. The complexity of a massive code base with so many developers working on the same projects in Java and C++ led to brittle code, low readability, diminished developer velocity and productivity. And Go's vision was, let's prioritize scale, which means accounting for how modern software is architected, the environments in which modern workloads run, and most importantly, the teams that write, operate, and maintain it all. So on that basis, from when Rob and Robert started in 2007 to when Go 1 was released in 2012, the Go team worked to define Go's founding principles and build it for release. This includes making it an open source project, which we did in 2009, and then ensuring that what we call Go 1.0 is usable in part by putting it in production, primarily at Google, but also beyond. Now, one of the key bits in Go 1's release notes was this emphatically stated point: the driving motivation for Go 1 is stability for its users. People should be able to write Go programs and expect that they will continue to compile and run without change. Some programming languages are good at this, some are not. We're going to be good at it. In fact, we released Go 1 with a separate document that explains our compatibility guidelines in detail, the Go compatibility promise. There, we wrote, it is intended that programs written to the Go 1 specification will continue to compile and run correctly, unchanged, over the lifetime of that specification. Go programs that work today should continue to work even as future point releases of Go 1 arise. And the reason the compatibility promise is so important is because what we sought to release in Go 1 was not just a programming language, but rather a platform for software engineering. The vision was not to come up with a new syntax or to compete with C++ on the number of new features we were releasing. The vision was to facilitate real-world software engineering at scale. This sort of software is written in teams where members come and go, where there are deadlines, SLAs, things like that. And that sort of software engineering really requires long-term predictability, not breaking existing code or creating a perpetual maintenance burden. It also requires accounting for the fact that software development is more than just the programming language you use. It's a multi-stage life cycle with intersecting tools. And that's the idea of a platform. In addition to the compatibility promise, Go 1 shipped with all this stuff on the slide out of the box. Instead of importing a third-party library for testing or finding and agreeing on a style guide, Go 1 started on this mission of providing our developers an entire platform for everything you need to ship good, scalable software in teams. All this stuff came with Go 1 out of the box. And in what ended up being another important decision, this stuff that came out of the box was all accessible from a single command. I'll elaborate more on why this matters later, but we can already begin to see at this point that Go is mindful of every link in the development chain, all the way up to the developer's command line. With the Go command, we established the first developer touchpoint, the entry into our platform, and one that continues to be a very important means by which we're able to ship a unified end-to-end experience. So that was version 1. Next, between 2012 and 2015, as developers were beginning to adopt Go, we focused our efforts on refining everything. You know, like any software project, especially one of this size and magnitude, the first few versions have all these rough edges, and there's nothing like real actual usage to help you see that. Finding those edges, prioritizing our efforts, smoothing it all out, that's a multi-year process that culminates in 2015 with Go 1.5. By Go 1.5, some of this heavy lifting is finished, and the platform is now refined. For example, the compiler and runtime were completely rewritten from C to Go. That's sort of this important rite of passage for a programming language of this sort, where the compiler is written in the language that it compiles. And Russ Cox has a great talk on this that I'd encourage you all to look up online, how they did that without breaking anything. The garbage collector was another sore point in the very first releases. It was really slow, but we introduced a new garbage collector in Go 1.5, which reduced overhead and reduced pauses to acceptable levels, something like what you saw in other language runtimes. Stepping back to the project level, it turned out that a predictable release schedule provided developers and projects a lot of value because it allowed them to plan their own release schedule around ours. So Go 1.5 is the first version where we committed to this semi-annual release process, and that persists to this day. And more generally, Go 1.5, in 1.5, the standard library was hardened, runtime performance was improved, and various other things were fixed or improved throughout. And despite all this change, the compatibility promise from Go 1 applied. So as we wrote in those release notes, version 1.5 is a significant release, including major architectural changes to the implementation. Despite that, we expect almost all Go programs to continue to compile and run before, because the release still maintains the Go 1 promise of compatibility. Now, we saw on the slide earlier that Go 1 had a primitive form of dependency management, but in 2018, modules were introduced, which really represented a fundamental shift, both one, in the way Go code is written and packaged, and two, how Go code, especially third-party libraries, was distributed, and then the ecosystem that followed that. So to this distribution point, before modules, you would go get your dependencies directly from their origin on GitHub or wherever else. And the introduction of modules alone didn't change that. But an important property of modules is that their contents for each version are immutable. And this provides opportunities for caching and authentication. So modules themselves were introduced in Go 1.11 and Go 1.12, along with the Go mod file and the Go mod init command. And these things fundamentally changed how Go libraries are packaged and versioned. But in Go 1.13, we took advantage of that immutability property that I just mentioned to introduce the Go module mirror and checksum database. With the module mirror, now we could cache all these libraries, and because we know they're immutable, we can serve them much more efficiently, which makes dependency downloads much faster, and by caching them, we can protect you from dependencies disappearing from their original locations. Separately, with the checksum database, we were able to store a hash of all the source code in these dependencies, which allows us to detect whether the source at the origin has changed since we first saw them. This protects against man-in-the-middle attacks and other tampering of your dependencies. Now, the module mirror and checksum database don't tell you whether a dependency has a vulnerability to start. What we do is by recording the hash the first time any Go user imports a dependency, we can detect whether that module changes on any subsequent import by any Go user anywhere. So in this way, the module mirror and checksum database are able to ensure that the bits you or anyone else gets the first time are the very same bits everyone gets every subsequent time. And this capability started a new parallel consideration for our development focus. We realized that as Go was growing, especially in huge important infrastructure projects, the importance of security was growing as well. So in addition to being a complete, refined platform for software engineering, Go also sought to be a secure platform for software engineering. So we talked about modules and the module mirror and the checksum database. Around the same time as that, we started seeing a lot of really high-profile software supply chain attacks. The kind of thing where an attacker would inject a vulnerability in a commonly used open source library, and this would affect a huge swath of the language ecosystem. You can think of Log4Shell in Java, for example. And that's where we really leaned into Go's security posture and capabilities. In Go 1.18, we introduced support for SBOMs, or software bill of materials. This means that the Go compiler writes into every binary that it builds all the versions and dependencies in the source, which allows you to later verify that everything is correct with just the binary. In Go 1.18, we also introduced a built-in fuzzer, the first major programming language with native fuzz testing built into and integrated in its standard toolchain. You can think of fuzzing as a form of automated testing that sort of intelligently manipulates your program's inputs to flesh out bugs, especially security vulnerabilities. Because of the module ecosystem and checksum database, you can fuzz a specific version of a module and know that it was correct. If you discover a vulnerability, you can report the results of the fuzz test to the package maintainer, and the maintainer can reproduce your results guaranteed. And most recently, we've released into public preview our end-to-end vulnerability management system, which surfaces known vulnerabilities in your dependencies everywhere from your IDE to runtime. This last one is ongoing, and it deserves a little more time, so I'll elaborate on it in the sections that follow. Now, the introduction of modules and the security focus that followed coincided with another important development. Go was becoming increasingly important in industry. For one, the entire cloud was being built on Go. This includes GCP, AWS, Azure, and all the different important tools and services that were becoming a core part of cloud-based software development. Enterprises began to adopt Go as well, using them for really important business-critical systems and infrastructure. And inside the Go team, all this use and adoption led to this sort of acknowledgement of Go's criticality, a realization that attacks on Go can be particularly harmful, which validated our focus on security and made it even more important. So I mentioned that a lot of security stuff came out in Go 1.18, but there was also another important non-security related change in Go 1.18, and that's generics. Generics were the single most requested feature of all time and the single most significant change ever made to the language. In the years leading up to the release of Go 1.18, there had been a lot of talk about doing a relatively larger overhaul that we'd call Go 2. I watched Steve give this presentation in 2017, and he's had a lot of talk about Go 2 and how exciting it was that we were starting down that path. The Go compatibility promise I showed you earlier actually specifically carves out a possibility for a Go 2, one that would be potentially incompatible with Go 1. And leading into the work that eventually became Go 1.18, we realized this might be Go 2. Generics in particular were not only the biggest change we ever made to the language, they're likely the biggest change that will ever be made to the language. But it wasn't Go 2, it was Go 1.18. And the question that always arose with that caveat in the compatibility promise was, when will Go 2 happen? Last year, Russ announced the answer is never, or that it's already happened. There will not be a Go 2 that breaks Go 1 programs. There will be major revisions like we saw in Go 1.5 and Go 1.18, but they won't break your programs. Instead, we doubled down on compatibility because it's far more valuable than any possible break with the past. In fact, we believe that prioritizing compatibility was the single most important design decision in Go 1. As always, every release of Go has and will maintain the Go 1 promise of compatibility. And that brings us to today. Now, thinking back to that history I laid out in that last section, you can imagine like a series of layers that are built on top of each other. The core stuff like the language, compiler, runtime, and standard library are introduced in Go 1. Modules were this paradigm shift that began in Go 1.11. And our latest security focus, that stuff beyond modules, really begins at Go 1.18, where we introduced SBOMs and fuzzing, and now we're on to vulnerability management. The next important piece to consider is how we continue to provide a platform. I emphasized the significance of the Go command earlier in Go 1, and that's an important developer touch point and the means by which we're able to ship this unified end-to-end experience. But along the way, we also expand into other important developer touch points. And these enable us to really expand our definition of what it means to be a platform. So the Go command itself, of course, is the original and most important, the one you get at the command line. But our web properties, go.dev and package.go.dev, these enable us to provide a rich experience for ecosystem discovery and documentation. For example, recently added vulnerability data to our package site, bolstering the ways in which we're able to deliver security-related information to Go developers in more stages of the software development lifecycle. And more recently, in 2020, we took ownership of the Go plugin for Visual Studio Code. This allows us to consider how developers can use the things that we build at the earliest stage of their work process, in the IDE itself. So when we released generics in Go 1.18, for example, we're able to ensure that generics were available in the IDE and VS Code on day one. And vulnerability data was recently integrated in there as well. We also have the Go Please language server, which Rob and Alan will tell you about a little later today. And that serves as an important means by which we're able to support VS Code, but also Vim, Emacs, and all the other editors our developers want to use. So that's the platform as it exists today. Let's take a look at adoption. So I'll start by saying there's a lot of different ways to estimate how many Go developers there are, and it's really difficult to land on a particular way of measuring this. So in this case, what I've done is I've taken the proportion of respondents who report using Go on Stack Overflow's annual developer survey, and I've multiplied that by /data's estimate of the global number of developers worldwide in each of these given years. So when we look at that, the state of Go looks really strong. We had 3 times the number of developers in 2022 as we did in 2018, and between 2021 and 2022, we took on 1.2 million new developers. That's a lot of new developers, and I'll return to that observation a little later. So, also, existing developers are extremely satisfied. So not only are we growing well, but once developers use Go, they are overwhelmingly satisfied with their experience. This is important not just because it validates our work or bodes well for future adoption. It also means a lot for team happiness, culture, recruiting and retaining talent. It's part of that core mission of optimizing for software that's built in teams. And we think there will be more of this to come. Go is consistently in the top languages developers want and plan to use. And 2023 is no different. This slide is from earlier this year, and it shows that more developers say they plan to start using Go than in the next 12 months than any other language. And I think we're sort of used to hearing stuff like this by now, but it's really remarkable, and it's a fantastic leading indicator of what's to come. So, and that brings us to how we think of Go today and the work we're doing now, and how we'll continue to pursue the core vision that started this project in the first place. All those things we learned in the last 13 years, the things we focused on, the impact we had, it all sort of reduces to this mission, the title of this slide. Go provides the most productive platform for building production systems. It's productive because it's easy to learn and maintain and scale across teams. It's a platform because it's more than just a language, it's an end-to-end developer experience. And it's production ready because it's reliable, efficient, stable, and secure. This framework is how we think ahead. Now for where we're going next. First is the work we have underway for making Go more productive. We released generics last year in Go 1.18, but we continue to improve on it now, including in the standard library. We're also making sort of ergonomic changes to the language itself, including a long-sought proposed change to loop variable semantics and another for standardized iteration. We're improving onboarding. You know, as I said earlier, we take on a lot of new developers every year. From the Stack Overflow number I showed you, more than 1/3 of Go developers only started using Go in the last year. And as we saw on the slide from earlier this year, more developers say they plan to start using Go than any other language. So we need to think of these developers and their experience so that they can quickly get started and be more productive, and then to also continue to be productive after that. I should say that we think of onboarding really broadly here. You can even think of things like error messages, linking, or documentation improvements. All these things improve onboarding. But all these things, they help new users be more productive, but the important side effect is that when we help these new users be more productive, we almost always help all users, all of you, be more productive as well. Next, we continue to think of complete cohesive solutions that reach all of our developer surfaces. Remember, it's not just a language, it's an experience. For example, this year we're planning to survey package maintainers to understand what we can do to better support the package ecosystem that is this huge part of what makes Go powerful today. We also continue to make our developer touchpoints more useful and robust. As I said, later today, Rob and Alan will tell you about the scalability improvements to Go Please that they've led. And our VS Code plugin continues to get better and more integrated, including by integrating with our new vulnerability management system, which brings us to vulnerability management, which, as I said, is in public preview now. But what is it anyway? Well, it really deserves a talk on its own, and you can find more info online or on our blog. But the short of it is that the Go team has created a comprehensive data source of all known vulnerabilities in the Go ecosystem, which we've done by pulling vulnerability data from all this variety of places like GitHub security advisories or direct reports from Go package maintainers. Vulnerabilities from all of these sources are then individually reviewed and curated and then aggregated into the Go vulnerability database, which is sort of this one source of truth for all Go vulnerability data. And probably most importantly, we've made all this data easy to find and use, most of all by integrating it across all of our developer touchpoints. So you can learn about the ones that might affect your dependencies on our package site, say before you choose to rely on it at all, or maybe for more information on something you're already using. You can use our command line tool, Go Vuln Check, to check at the command line or in CI. And you can detect and fix vulnerabilities in your IDE, as well as through our integration with our extension for VS Code. So this is the latest example of how, by focusing on building a platform, we're able to create end-to-end solutions at all stages of the software development lifecycle. Finally, we continue to make Go production ready. Performance and reliability are a huge reason developers choose Go, and we want to be sure that we're still leading the way. So, having doubled down on compatibility, we've taken steps towards ensuring that you can, if needed, emulate behavior from older versions of Go. And if the loop variable fix I mentioned as part of our productivity work surfaces a bug in how your existing code uses loop variables, we'll make it possible to force compatibility so you don't have to worry about breaking when you upgrade. On the performance debugging and monitoring side, we're exposing more metrics for the garbage collector, writing a garbage collector guide, working on execution tracing, and ensuring that Go works better with the Linux perf tool. And our standard library is seeing some really important new functionality as well, like structured logging, Quick, and HTTP MUX. Which brings us to the last section. Even if we're doing all that work to make Go the most productive platform for production systems, why do we think we'll succeed? Well, the answer is right in front of us. It's Go's community. Since I started on the Go team a few years back, there's nothing that has impressed me as much as this community and the culture that you've all built. The Go project itself, so not even counting the ecosystem, is this vibrant community of developers from all over the world who vote, comment, and contribute to this enduring project. And it's consistently growing, almost 2,000 contributors as of last week when I took this screenshot. There's a large, robust library ecosystem as well, almost 1 million different modules. This is one of the most important things we have and what I think we need more of. Quality libraries make everyone more productive and unlock these new opportunities that we as the Go team could never foresee. And we see Go really thriving in open source, which really bodes well as a leading indicator of what we think we'll see in industry next. You know, programming language adoption, especially when you view it in the aggregate as like many rankings do, it's fundamentally slow. A lot of stuff's already been written and developers continue to maintain or build on them, and it would be really inefficient for them to go back and rewrite these workloads in a new language. Nobody wants to fix what isn't broken, and we don't want that either. Our objective, our opportunity, is to target new applications. So on this slide, we plot out the proportion of pull requests on GitHub by language per quarter for each of the major statically compiled memory-safe languages: C#, Java, Rust, and Go. It isn't aggregated over the last 20 years like you'll find in a lot of other benchmarks or surveys that ask developers, what languages do you use? This is a quarter-by-quarter breakdown, so it's more of like a first derivative. And it's actual work. It's measured in pull requests. And as you can see, Go's ascent, which is in red here, it's really pronounced. In the last few quarters, it's practically tied Java. And that's really exciting for all of us. First, because Go is growing in open source, it means there will be more libraries for developers to use, furthering that flywheel of productivity and adoption for all Go developers, and furthering the vision of a really productive, secure platform for production systems. And even more than that, it means that Go and the Go community are well positioned for the future, ready for the big shifts in technology that happen from time to time. Go and the Go ecosystem are better than ever, ready for those moments when new code is written. But for all of that success and excitement, it always comes back to you, the community. We know that there are millions of developers who are actively using Go to build their applications, and we know there's going to be a lot more to come. But even more important than that, there are hundreds of thousands of Gophers around the world who meet up, they come to conferences like this because they love Go. And that's irreplaceable. And that, most of all, is why the state of Go is strong. And that's it. So thank you, and let's have a fantastic conference.